Hello, we are Edgar, Michelle, Gemma, and this is our K activity. The projectile motion is when an object is projected into the air. It is the way of motion where an object moves in a parabolic path. For the projectile motion to happen, there has to exist one force applied in the start of the path, and the only interference in this trajectory can be the gravity. The components of projectile motion are initial velocity that is expressed with x and y component, the velocity that there exists, the horizontal velocity that remains constant, and the vertical velocity that varies linearly. Also, there is maximum height, and maximum height is reached when the velocity equals zero. Acceleration is in the projectile motion in vertical direction, and this is because the gravity. The range of the projectile motion is get when y equals zero.
So we saw a lot of experiments doing the research, but we stay with this one that it's a canyon. We choose it because it's simple to represent the projectile motion, and also it is made with things that we already have at home. Like it will be one balloon, a one 10-centimeter cardboard tube, the ones that come in the toilet paper, a piece of cardboard that this one helped to maintain the angle every time, a small bouncing ball, a measuring tape, and a scotch tape, and 1 cinch.
So in this experiment, what we did, as you can see, is first a horizontal shot where Gemma, she intended to shot this projectile from a fixed height. And in order to get initial velocity that was fixed, we will use it to compare it into the other experiment that will give us other answer to that initial velocity. And here, as you can see, it was this table from those variables that we get, and 2.35 was this initial velocity that we calculated. Then Gemma, she started to do some trials from these experiments of projectile motion, where she used the canyon in order to calculate initial velocity. And here we got the data collection from those trials that she already did. In these trials, she recollected those main variables as independent, the displacement and the time, that later on she used it to calculate those initial velocities. And obviously we had to use some control variables, as the angle was 60 degrees, the initial displacement and height were fixed to 0, and then we ignored the resistance in this experiment. So this purpose was to compare both the fixed initial velocity and the calculated one in this table. As you can see, we used a calculator error, or a median absolute deviation, that we use in order to make a prediction of what was this mistake produced by those trials, or like the deviation that we did on those trials. And here you can see that we got some average displacement time, and then we just added or subtracted to those averages, and we got the approximation. The approximation of this velocity was 2.53 meters per second. Also, there was an approximation of a maximum height of this projectile motion. and we compared both variables.
Conclusion, or with this project, we developed the skills to identify the most common errors in a physical investigation and to know how to execute it correctly again. We were able to identify the scenic components of the projectile motion and identify it in everyday life.
Finally, there are so many ways that we can improve this project that it can go from the construction, because the materials that we use were things that we already have and the presentation wasn't that quite good. Also, the recollection of data where it was quite difficult because one person did it, and maybe if all the team have participated, it will be a little more easier. Also, if we had organized better, maybe the presentation of the videos that show the recollection of data will be quite good. So there are a lot of things that we can improve, but with this we learn also. So
So that was it. Thank you.
Mhm.
Thank you so much. We have some, yes,
and now we are gonna show the bibliography.
yes, that was the